Good morning, scholars. Welcome back to the channel. This morning we're going to be introducing percentages. So we're looking at expressing percentages and actually writing them as fractions, right? So the key point to note is the meaning of percent. Now remember, I always say when you're doing math, you should always have your dictionary next to you, because things get names based on what they are, right? And many times, especially in math, you will find that the names of things originated in whether Latin or Greek or Hindi, right? The languages or Arabic. So we can trace the roots of some of these words, and it will make us better able to understand what exactly is this word, what is this concept, right, that we're talking about. Now we're looking at percent. Breaking it down, per means the prefix. A prefix is a part of a word that goes in front of another word. So it's attached to the front part of a word, and it changes the meaning, or it modifies the meaning of that word. So per means for every, for each. So for every this amount, then something else, right? For all of these, then something else. So what comes after the per? Cent. The prefix cent means 100. The base cent means 100. So percent, then putting them together, means for every 100 things, for every 100 units, for every 100 units, we're going to take this amount out of it. So if we say 5%, that means out of this 100, out of these 100 things, we're going to remove 5, or we're talking about 5 of them. We're singling out this 5 for whatever reason. So if you did an exam and you got 83%, your score was 83%. If it was 100 questions that you had done, it means you got 83 of them correct, right? Or the equivalent, if you did 50 questions or 25 questions, the equivalent of what you got out of the 50 or out of the 25 would be the same as saying 83 out of, or 80 whatever out of the 100. So then, I'm just going to do 3 actual shading to show you what we mean. So I've divided these 3 squares. They're not perfect squares, but they should be perfect squares. So think of them as perfect squares, right? So it's 10 by 10, which you know would give 100. So each of these is divided into 100 units because we're talking about percent. And this is the sign that we use. Wherever you see this sign, it means percent. Out of you're evaluating the amount out of 100 units, 100 parts. So this says 71%. If we were to demonstrate 71% of this square, we would have to shade 71 boxes out of 71 of the tiny squares out of the bigger square. Because remember, the big square is divided into 100 tiny squares. So we would have to shade the first 10, so that's 10, 20, 30, 40, 50, 60, 70, and then just one more out of the other set. So we have shaded 71 of the tiny squares out of the big 100, the big square that's divided into 100. And that's what 71% means. 71 out of 100. Likewise, 28%, since percent means for every 100, So for each 100, we're going to take 28. So we can shade 28. So that would be 10, 20, because they are groups of 10, and then 8 out of the next batch, right? So 10, 20, and then 8, so 2 are left from that batch, 28%. So if 28% is taken out, then what percent would be left? If you remove 28% from something, what percent is left? You simply take 28 from 100. So the amount that would be left would be 100 minus 28, which I believe would be 72%. And if you were to remove 71% from anything, what percent of that thing would be left? That would be 100%, take out the 71, and I believe that would give you 29% left. Okay, double check it for me. 16% would be 10, 10%, and then 6 more. So that represents 16% of the whole. Because remember, the whole square was cut up, divided up into 100 equal tiny squares. We're removing 16 of them, or we're highlighting 16 of them. We're referring specifically to 16% of the whole. So that's 16 shaded. So what percent would be left? If we remove 16%, then 84% would be left. Right? So whenever you want to see what percent is left after you take out a certain percent, just subtract from 100, since 100 represents the whole. It's divided into 100 parts, equal parts. So percent means for every. 100% then would be 100 out of the full 100, which is one whole. It cancels down to one whole. 100 goes into itself one time. So if you're talking about 100% of anything, you mean the whole thing, the entire thing, all of it shaded, or all of it highlighted. We're talking about every part of that thing, 100% of it. Now these are percentages that you should know by heart because they are very common. You'll meet them in maths. You're going to be meeting all of these: the 100%, 50%, 75%, 25%. You have a couple other common ones as well, and you should know how to express all of them, which we are going to do many examples this morning. But these ones are very, very, very common, very basic. So let's work these ones down. We know 50% would be 50 out of 100. If we reduce that, so we know we can cancel zeros in pairs at the end, which means we're dividing by 10. And then 5 goes into itself once, 5 goes into 10 twice. So 50% is a half. You should just know that. Just know that. 50% of something means a half of that thing. Okay? 75%. So 5, you can divide by 5, or for those who, you have some really smart guys who know their 25 times table, right? They know that 25 goes into 75 3 times. Or you can divide by 5 and then divide by 5 again, right? So it goes into that, and there are 4 25s in 100. The 25 times table is pretty easy to learn though, guys. Just think about it, right? So you have 25, 50, 75, 100. 4 of them in 100, and then you start all over again for the next batch. It's pretty easy. So there are 3 25s in 75, 4 25s in 100. Therefore, 75% is the same as saying 3/4. Know this one too. Just know it. Just know it, okay? And 25%, so there's 125 in itself, 4 25s in 100. So that's a quarter. So these 3 you must always have them ready. Always have them ready to go. Pre-packed and ready. 50% is a half, 75% is 3/4, and 25% is a quarter. Alright, so let's look at some other ones. Now when you're changing percent to fractions, since you know that percent means out of 100, you can just go straight. 10% is 10 over 100. 10 out of 100. And then reduce it. Right? Just reduce it. So that 0 cancels that 1, meaning we divided them both by 10. So what we're left with is 1/10. So 10% is 1/10. 20%, 1/6%, it means out of 100. So it's 20 out of 100. Those two zeros cancel, reduce, divide by 10, we reduce them. 2 into itself, 1, 2 into 10, 5. So 20% is 1/5. 1%. 1% is simply 1 over 100 and it cannot be reduced. It's just 1. Cancel it by 1, you're going to get the same 1. 1 over 100. So that's as simple as it's going to get. 45%, so that's 45 out of 100. Let's use 5 to reduce it. 5 goes into 45 9 times. 5 goes into 100 20 times. And this is in its simplest form now. So 45% is 9 out of 20. 9/20. 62%, so that's 62 out of 100. Let's use 2 to reduce it. So 2 into 6, 3, 2 into 2, 1, 2 into 100, we know that's 50, right? You must just know that. There are 2 50s in 100. And so our final answer is 31/50. 31 out of 50, which is in its simplest form. No, it cannot be reduced. Alright, so let's look at these now. 30%, so that is equal to 30 out of 100. These zeros reduce, and we're left with 3/10. So if you got 10 sums to do, and you got 3 right, because you didn't practice, you didn't watch the videos, you didn't practice yet, so you got 3 out of 10, then your score would be 30%. Okay? Your score would be 30%. After you practice and you watch the videos and you study your books, then you're going to get your 100%. Alright, so 9%, that's 9 out of 100. That is in its simplest form. It cannot be reduced. 2%, 2 out of 100. 2 goes into itself once, 2 goes into 100 50 times. So that's 1/50. 12%, 12 out of 100. Using 2 to reduce, so 2 into 12, 6, 2 into 100, 50. It can be reduced again. We can use 2 again. So we could actually have used 4. For the smarter guys who are on top of things, you know that the bigger the factor that you use to reduce, the quicker you get it done. If you use a smaller factor, you have to do it again. Alright, so 2 into 6, 3, and 2 into 50, 25. Our final answer for 12%, 3 out of 25. 28%, so that's 28 out of 100. We're going to use 4 this time. We're not going to make the same mistake like we did with the 12. We know that 4 can go into 28. We know that 4 can go into 100. If you use 2, you're going to have to cancel another time, right? So we are on top of things. We're just going to go straight and use the 4. So 4 goes into 28 7 times. 4 goes into 100 25 times. The final answer is 7 over 25. 28% in its simplest form is 7 out of 25. Alright, now we're going to do another batch. You know I love when my students practice. I like to give you lots of examples so we can go through them together and look at the different ways that they can come. I love to do that. So when you're watching my videos, just make up your mind to be going through lots of examples. And this is good for you. Practice is excellent. Excellent work. So 60%, that's 60 out of 100. We know that these two zeros can cancel each other out, meaning we just divided both terms by 10. That's what we're doing. When you see me draw a line through the two zeros, that means I'm dividing each of those by 10, so I'm just getting rid of the zero at the end. That's what happens when you divide by 10. You can just drop the zero from the end of the number. It's another shortcut in math. But we're still left with 6/10, which can be reduced. So 2 into 6, 3, and 2 into 10, 5. Okay? So 3/5 is our final answer. 85%, that's 85 out of 100. We know that 5 can go into any number that ends with a 5 or a 0. We know that. So let's divide by 5. 5 goes into 8. 1 time remainder 3. 5 into 7, 35, 7. 5 goes into 120. And that's 17 out of 20. Okay? 15%. 15 out of 100. Using 5 again. 5 into 15 goes 3 times. 5 into 100 goes 20 times. 3 out of 20. Alright, winding down. 70%. That's 70 out of 100. Zeros at the end. Cross 3 zeros. Just be stylish, right? It's a stylish thing. We just cross through the zeros. And we're left with 7/10. 70% in its simplest form is 7/10. 7 out of 10. 11%, that's 11 out of 100. It cannot be reduced. 11 is a prime number, so only 1 and itself can go into it, and 11 cannot go into 100. This is the simplest form. Likewise with 23. 23 is a prime number. Only 23 and 1 can go into 23. It cannot be reduced. If it could go into 100, we could reduce it into 100, but it can't. It can't go exactly into 100 without a remainder. So these two are in their simplest form. 33%, I believe that too is in its simplest form. There's nothing, 33 is not a prime number, it's composite, but no factor of 33 is a common factor of 100 except for 1, number 1, which if we divide by 1 we get the same result. So 33 out of 100 or 3300 is in its simplest form. As big as those numbers seem to be, the fraction is actually in its simplest form. And 19 out of 100, again, 19 is a prime number and it cannot go into 100. This is the simplest form. So sometimes when you express the percent as a fraction, you just have to leave it like that because there's nothing more that can be done. It cannot be reduced. Don't stress yourself out to think that you must be able to reduce it. If it cannot be reduced, it cannot be reduced. Just leave it as it is. Or you can make a note to say simplest form, right? It cannot be reduced. Finally, I threw this one in 120%. So you must be saying, but 120 is bigger than 100. How can you have, if 100 is the full whole, 100% is the full whole, how can you have 120%? Yes, you can. What that means is you will have a full whole plus a fraction part of it. So you've started forming another whole. Not complete yet, but you've completed one whole and you started forming another whole. So we can still cancel the zeros at the end, and we can cancel the 12 and the 10. 2 into 12, 6. 2 into 10, 5. 6/5. 6 over 5 is an improper fraction. 5 goes into 6 one time, remainder 1 over 5. So just like I said, we have one whole and then we started another whole. We have completed one part out of 5 parts of that whole. Okay, moving our way up to 2 wholes, which would be 200%. Okay, so 120% is one whole and 1/5 of another whole. Okay, guys? So that's it. Percent means 100. If you're expressing a percent as a fraction, just rewrite that percent over 100 and reduce the fraction if you can. If you can't, leave it as is, or you can make a note to say it's in its simplest form, cannot be reduced. So if you have been helped by this video, please drop a line to say thank you, miss, and share the video with your friends, classmates, siblings, cousins, auntie, uncle, grandpa. Yes, grandpa wants to learn fractions, okay? He does. So you can do it with grandpa and grandma, auntie, and everybody. And if there are other topics you want me to do videos on, please let me know and I'll do that. I'll see you in the next video.